Hello, everyone. So today we have in our podcast Professor Peter Finke. He has done research on soil science, geochemistry, and soil mapping techniques. And also he has already published more than 150 papers and more than 6 books, already 6 books, author and co-author, and he also teaches subjects as earth and environmental science, history and archaeology, agriculture and food science, chemistry, and so on. He was also one of my teachers at Ghent University. I had a pleasure to be one of his students. And also, most importantly, he is an IMSOGLO program director and academic coordinator at Ghent University. Welcome to my podcast, Professor.
Thank you. Nice to be there. Yeah.
Yes. So, as I said, we will start discussing with the IMSOGLO program. I'm a master's student at IMSOGLO program, and most of the students, when I say IMSOGLO, they are surprised and they want to know more. And today I have Professor to really tell about in detail what's the program and what was the need and motivation for this master's program to be organized as it is today. So I will just give the word to Professor.
Yeah. Okay. Thank you. Yeah, it's a good question, I think, because such a program, it doesn't fall out of the air. You have to do a lot of work to get it started. So there must be a good motivation. Otherwise, you can save yourself the work. And what was the reason to do it? Well, I know, because I'm already a little bit older, quite a number of people in Europe that are doing research on soils. And also I know a little bit about their education activities, their teaching activities. And the complaint or the observation that I have and that many others of these teachers also have is that soil science education is a little bit scattered. So that means that many places of Europe, you can get some soil science courses, but very broad set of courses are very rare. And especially many of these courses are not so much tailored towards the current problems. And the current problems are what is the effect of soils on climate change? Think about carbon sequestration. And also the other way around. Is there an effect of soil management on, for instance, the amount of CO2 emissions to the atmosphere? That is one of the many examples that you can give. Now, many places in Europe, people were doing research on that, were giving courses on that, but it was never in a full master program. So then I thought, let's try to bring these people together, because maybe all these groups together are able to have a full master program on this topic. And that was successful, apparently. That's still a long way that you have to go. First, you have to define what you think you can do. And you have to think about activities that are best done by some of the groups and activities that are better done by other groups. I think most of the groups could probably give 80% of the courses of the program also via their own curricula, but nobody can give it for 100%. So then you have to start making some kind of division, and you look for the strength points of each one of the groups. And that's how it started. So we first defined what should be in there and who should probably do it, because they are the best equipped groups to do it. And then the second stage is, of course, okay, you want to teach, but who are you going to teach? And then you can say, we just set an advertisement and then we see who comes. But there is some arrangements in the European Union with Erasmus that you can get funding for scholarships. And that means you have to write a proposal, and that is a huge proposal, hundreds of pages. And it's evaluated very strictly. And then, if you are lucky, you get elected. And then you have 4 years of funding for scholarships. So we were lucky to get this funding, which means that we had, over a period of 4 years, I think 94 scholarships altogether for people from all over the world. A certain part should go to Europe. A certain part should go to certain, let's say, target countries. So that's Africa, Central Asia, etc. And there is a third group that can be the rest of the world. Let's say it like that. And this is how we have to every year select students from these different groups. And that's based, of course, on their shown interest, on files that they submit to us, etc. So that's how it got started. So we have the first intake in, 2019? But the program was already written a year and a half before. So that means you have a really long preparation time, and you also need it because you have to set up an organization that's able to do it. Things, most of the management type of things are done in Ghent, but every local university also has its management activities. Like you are now, where you are now, you have to do something related to the management to get your transcript of records of that university out, for instance, and to organize the courses. So there is a lot of work that has to be done by the different partners, and all this has to be defined in advance. Mm-hmm. So that's how it was initiated. And the motivation, let's go back to the motivation. It was just that everyone in these different groups had the feeling, well, we can do part of this hot topic of today, climate change and soil, but not all of it. So let's do it together. That was the motivation. It was actually very simple motivation, but I think simple motivations are usually the strongest because you can explain them also to someone who has to pay you for it.
Exactly.
Yeah. So that's basically how it started, and from that. We had a program defined from the beginning, and over the years, some very small modifications have been applied because you can always have a situation that somebody retires and you need a successor teacher, which may mean that the focus is going to shift a very little bit. But most of the changes were rather limited. So the program that we are now starting in year 4 in September will look quite like the program we started the first intake in 2019. Mm-hmm. So that's so there is a bit of evolution in there, but it's not dramatic.
Yeah, as one of the students who is doing this master program, mm-hmm. I was very interested. How did go the university selection? Because there are 4 universities.
Yeah,
Ghent University first, and then Aarhus University there, Vienna, BOKU, mm-hmm. and then Gottingen University.
Yeah.
Why these 4 universities were selected?
Yeah, okay. Well, I said it a little bit. It's based on the expertise, and it was also based on the people that you know. Because, mm-hmm. for instance, we have long-standing collaborations with Aarhus. Many people in Ghent work together with people from Aarhus. Actually, a number of teachers in Aarhus were actually educated in Ghent. So there is really a close connection. Mm-hmm. The BOKU, there are many exchange contacts already before. So we knew the people over there also quite well. And personally, I know a number of people, for instance, in Gottingen very well. And I knew that they would be able to deliver some of the activities that are needed in the program. So mm-hmm. it is very much based on personal experiences and knowledge about the level that the groups have. So if you have to write such a proposal, you have to, for instance, you have to show some kind of proof that they are academically at the right level, at a high level. So for that, you have all these rankings. You have so many rankings. Every university can find the ranking in which it is good. But mm-hmm. but anyway, we had some comparison. We knew that some people would be interesting, but we also checked the quality of the universities, and then we are more or less on an equal level. So that's a good basis to start. Also, when you know people personally. So it is that's the reason. But it doesn't mean that we didn't ask anyone else. But sometimes there are very practical reasons not to do it. Mm-hmm. I should not maybe mention everything, but some universities we asked, and they turned out to be so expensive in terms of their tuition fee that it was unaffordable.
Mm-hmm. Maybe we cannot name you don't want to name the university, but maybe you can name the country.
Then I name the university directly as well.
Okay.
So that would be a little bit impolite to do that, I think. Okay. But there can be some, that's a restriction that was actually financial. Mm-hmm. The university would be very good, very well suited, but nevertheless, it didn't happen.
Something hints me. Well, okay, I wouldn't tell it. Again, coming back to this. The first you said that there was the motivation, but when you have the motivation, there are also struggles to face. And did you had some struggles when you were organizing this nice, super good as I would say, IMSOGLO program. Were there any difficulties you had to face?
There is, let's say there is continuously small difficulties, problems that you have to solve. And that is usually not because people are not motivated or not doing their thing right, but it's just because of things that change inside the university. Like I said, somebody retires, somebody goes to another university. Mm-hmm. Well, you know, an example from Gottingen.
Yes.
and these kinds of things happen, and these pose problems that you have to solve. So that is, there is always a problem to be solved. You could say it like that, but it sounds a little bit negative, and I would actually rather put it positively, because every problem that we have is always easily solved because people are always collaborating. Mm-hmm. They're always jointly cooperating to solve any problem that appears. So I wouldn't say that there is really that there are really big issues between universities. Mm-hmm. No, I don't think so.
And now coming back again to the IMSOGLO program, there are two majors: soil biogeochemistry and global change, and physical land resource and global change. Mm-hmm. I was very interested. Yeah, the structure of these two majors are very well done, and it fills all the requirements, which the names are as given such, like soil biogeochemistry and physical land resource. Why these two majors were the most important focus of this program?
It has, again, something to do with the organization that we had in the beginning. So we know we have 4 partners, and we knew in advance the very strong points of each one of the partners. And if you go then to BOKU and Gottingen, then they have more, let's say, more a focus on things like forestry, on things like greenhouse gas emissions as a function of the land use in forest or also agricultural land use. And it's rather biochemical. There's a lot of microbiology in there, for instance. While on the other hand, in Aarhus and Ghent, these things are also done, but we within IMSOGLO, we are more focusing on, let's say, soil threats, soil health, these kinds of things, and they have a little bit more of physical nature. So if you talk about erosion, then you're not so much talking about chemistry. And so there is a slight difference in focus, which is a function of the participating institutes and the tasks they identified in advance. It doesn't mean there is no overlap. There's actually quite a large overlap. I mean, you remember I was teaching you this horrible course of soil genesis, and it is what most people may think it's horrible because of the chemistry in there, while I'm a teacher in the physical land resources part of the program. So it doesn't exclude each other. So it's, so there is an overlap of maybe 40-50%, and the rest is different, you could say. And that is, to a large degree, it's based on a distribution of tasks that we envisaged in the beginning between the universities and the things that each one of the university could teach best. And altogether, the full focus of all 4 universities covers everything that we wanted to cover. So then it was reductionistic. You could say this is what we want to cover, 100%. Well, we take off 2 universities with their specialization, and we take 2 other universities, and can we still cover this 100%? And then the answer was yes, but then you end up with 2 specializations. That's how it very often goes. Yeah.
As you said before, depending on the university's focus and what they are good at, you said that there is also need for these majors. And I also see we'll discuss it in detail later, but I just want to cover it. There's also a need for soil modelers and soil AI or machine learning applications, statistics, data science and soil science. Would be in the future, there one more major covering this?
That's an interesting question. I totally agree with you that these issues like artificial intelligence, or maybe also if you expand a little bit, the use of sensors to do mapping and to identify processes, these things are becoming more and more important, and they are more and more, let's say, the hot items. today. So I can imagine that part of these are going to be integrated in the next version of the program, and we will be writing that next version of the program in September this year. We will start writing it because the period of 4 intakes is going to end now. The last of the 4 intakes is starting in September. So 2 years later, the program would normally be finished. But we want to have a successor program. So we write a new proposal, and then you have to say, what do you want to change? And indeed, these kinds of things may change. It is now, maybe now it's a little bit hidden, the use of artificial intelligence and also the use of sensors, not as a course in the program, although I told a little bit about it in my own course, Soil Prospection and Classification, but it's not in your specialization. But what you do see is that quite a number of students already do master theses in these subjects. So that means they can do the practical work, and they can answer the research questions, but they have to prepare themselves a little bit outside the regular curriculum to be able to do it. So I can imagine that in a future version you put some more emphasis on it. Now there is, for instance, there is statistics, but that's quite basic statistics, although it is not easy for many students to do it. You can imagine that there would be something like advanced statistics using the AI methods, using, let's say geostatistical mapping methods that are also quite important. Telling a little bit about it. The only thing we have to take care of is that the entrance level of the students is still matching with that. Because we have a few requirements. That's on the website. It's mentioned there. You need a certain amount of study points in these topics. And we found out over the years that especially the knowledge of statistics is for some people a little bit on the edge, if they can do it or not. Quite a number of people fail that course. So if you say, I want to do more on that, then you probably have to change your entry requirements, because otherwise there will be too many people failing exams. So everything you want to add has also consequences for the people you are going to take in. And all this we have to think about when we define the new program. But I agree with you that these things are quite important knowledge that you need to have. Yeah, sure.
Yes, I do agree that about failing the statistics. Myself, I failed it 2 times, and
okay, you're not the only one.
And also, that doesn't mean I don't like statistics. I love statistics. At the same time, I got interested in bioinformatics. Like for soil biogeochemistry, I see that some of the PhD positions, they require bioinformatics a little bit. And if that points would be a little bit like introductory course, I think that there would be very good students for the future, where they can apply advanced GIS and also bioinformatics, have an introductory course in bioinformatics. That would be great.
Yeah. Oh, we can keep it in mind. One of the things we are going to do when we are starting the definition of the follow-up program is we will ask alumni what were their experiences with the program and what would they suggest for improvements in the future. So that's an exercise we are going to start. I think at the end of September, we have a management board meeting, and then we define what we are going to do next. And we have to do a lot the rest of this autumn to define the new program. And one of the things is an alumni survey, not only asking what is your job, what kind of job did you get after your studies, because that's interesting, but also, what would you do? What would you have liked better instead of what you did now? So that was, these are the things that you can use to improve a program and to follow up on the developments in the field, because it's very easy to do 20 years the same, but it's not very interesting to do so for the students.
Yeah, exactly.
So,
I do agree. IMSOGLO has a very supportive group, and we always have meetings, and they're also in WhatsApp group. They ask for feedbacks. I would say it's the most friendly one of the groups exist in the world, like international program. Yes.
Okay. But that's a WhatsApp app group that is by the students, managed by the students.
Yes, it's managed by the students.
Yeah.
Students themselves, they are doing a lot more.
Yeah, so you're helping each other. That's very good. Yeah.
Well, I'm not helping as much as I should, but still. Also, now coming back to your work, it was interesting for me to read about you in the internet. Well, it was quite a lot. I couldn't read all of them, and I think it's impossible. In 2007, in an interview for International Union of Soil Science, for one of the questions, how do you see the future of soil science? You answered, in the narrow definition, soil science will probably live until the mapping is done, which end has been postponed thanks to the Commission on Pedometrics, but will certainly come. So it's time for the unlocking of soil science. Mm-hmm. And from that year, from 2007, it's been already 15 years. Yeah. And we see a lot of change in soil science. But for me, it's interesting to see from your perspective, how would you describe what kind of change happened after that year?
Yeah. Well, maybe first let's go back a little bit to that interview, because that interview was actually, what I said was a follow-up on an interview a few years earlier than that. Mm-hmm. And there I said, I think at this moment, and that was the moment that people were still making traditional soil maps and not much more. So we are talking about 1995, a long time ago. And at that time, I said, well, you got two types of soil scientists. The first type is the one that makes maps of the soil. Mm-hmm. And there is another type that does a lot of differentiating research on processes in soils, etc. But they often are not called soil scientists. They are called hydrologists, biogeochemists. They have different names. So that's actually for the name reputation of soil science not so good, because they are not called soil scientists. So I said you have a narrow definition and a broad definition. And I think we should look at the broad definition mainly, because what's in a name? I don't mind if people call me a biogeochemist. I don't mind it, but my profession is soil scientist. So I said then, if you have the narrow definition, then if the mapping is done, then you're ready. But in the wide definition, the world will continue to turn, and then a lot more will have to happen, because if you have made a map, then you maybe want to know, would this map look the same if we incorporated all the processes that are now going on? For instance, climate change, what does it do to a soil? Is the soil still going to be the same after 20, 100,000 years? That's the things we want to know. Mm-hmm. So that's why I said, let's uncloak soil science. So let's bring together all these people who do not call themselves soil scientists, but are actually doing research on soils. So that was the background of that. And then in 2007, I said, we are now still mapping. We are mapping with more advanced methods, pedometrics, for instance, very geostatistical methods, very advanced. That's very nice. And now your question is, what has been happening since then? And I think a lot has happened. First, the pedometrics community is still going strong. So they are still making ever more advanced mapping methods that they can use to make maps of properties very fast and at very high resolution. Okay, very good. But there is one or two more things that have changed or have developed very strongly. And one of them is the development and the usage of sensors to put in the soil or to put on top of the soil and then measure soil properties in an indirect way. But still, if you compare it to ground truths, it can be very efficient and very qualitative good. So people are now using sensors to put them on top of the soil to find out what is the clay content of the subsoil. What is the advantage of that? You don't have to dig a pit. It's much quicker. It's much more efficient. And people are now using it regularly for precision agriculture, for instance, to find out what are the differences in the fields. And can we take into account these differences when we are doing fertilizing or when we are doing, when we're doing irrigation, for instance? Or what is the risk that nitrate is going to leach out if we know the variability? So that's one thing, precision agriculture, but also for archaeology, people are using it to find out where are old remnants hidden below the surface without destroying everything immediately. Mm-hmm. And then there are even more. There is pollution issues that you can map with these sensors. And this has really taken a huge leap since the early 2000 years. So there is a big development over there. And I think there is still a lot of future there. People are now, for instance, I heard a story last week. Yeah, we have now something that you can push into the soil, and actually it's a lens. And this lens is going to make a movie of the soil when you push it in and you see all the layers. You don't have to dig anything anymore. Mm-hmm. And you also have equipment that you push in, a very thin rod, and it will make XRF. So that's an X-ray diffractogram. And it will give you immediately information about the elements that are in the soil. So if it is polluted, yes or no. Well, 10 years ago, this would be impossible. So this is a big development, and this is going to help us to be more precise, cover more variables, do it quicker, etc. So these are big developments that have been happening since then. And then the second development that I think is very important, but it's also my personal hobby, so maybe I'm a little bit colored there, but that's the modeling. In the past, that was already before the year 2000, people were making models, but it was basically on one topic. So I want to know about nitrates. Is it leaching out? I want to know about pesticides. Is it going wrong somewhere? And now you see that people are looking to more than one property at one time in those models. So the models become huge. They have a lot of processes in there. And then the question is, can you still predict something with these models? And that is a big area of development. And it allows you, of course, to take into account all kinds of interactions. For instance, if you're interested in carbon sequestration, you want to know how much carbon can be stocked in the soil over time in a changing climate, so into the future. Now, then you can use a model to do that, but then you can also take into account the effect of, let's say, the changing hydrological status. If the rain intensity is going to change, what would be the effect on the inclusion or the addition of organic carbon? Or what else is there an effect of on the soil pH to be expected, and will weathering go faster if we have more precipitation? So all these things, I think, in the future we will deal with a limited amount of models that have a lot of processes in there, and that's one big development that I at least also see, and many with me, I think. So these are the two big developments since 2007, I would say, the sensors and the modeling. These two.
It's also going to the future, sensors and modeling. And linking with our second question, actually, that the requirements are more data-driven for the future.
Yeah. It should be data-driven. And if you don't have the data, because for the future you don't know yet, you cannot measure something that still has to happen. For that reason, you can use a model. So if you have a model and you train it for the period of today, and maybe start in the past and go to today and see if everything is well predicted by the model. If that's the case, then you can project into the future. You just say, this model, it is driven by precipitation, temperature of the atmosphere. Well, let's drive it via a climate model and see what happens to the soil. And so if you cannot measure, then you can, in very many cases, model. So it's the combination of both that has really additional value, I think.
Yeah, we will discuss later on about soil modeling and soil mapping, but for our listeners, maybe it would be interesting also to know what is International Union of Soil Sciences. What does it do?
Well, it's more or less a union, like you have a union when you are working, the union that defends the interest of the group, you can say. And that's what the Union of Soil Sciences also does. So every country has a national board or a national club of people working in soil science, and they come together once a year, etc. And then they decide what they will do the next year. They have some excursion and things like that, but it's very local. In Belgium, they have a Belgium Soil Science Society, and I don't know how many members they have, but if you look to the LinkedIn group, it's about 140 people. So I guess this is about the number of people they are members. But the world is bigger than Belgium, I've recently found out. And that means that you have to take into account that in other countries, other things may be happening. So it's good to join forces. And that's why the International Union of Soil Sciences was established already a very long time ago, by the way. Very long time. I don't know how many years, I think maybe 100 years, something like that. So that means they are collaborating national unions. And they also have their own initiatives. And one of the initiatives is every 4 years, a very big congress. This year is going to be one in Aberdeen in Scotland. In Glasgow. Glasgow is not Aberdeen. Glasgow, but in Scotland. And there you will have probably some 2,000 or 3,000 soil scientists coming over and presenting their newest work in all kinds of sessions about topics that are separated from each other. And that's one place where you can meet your colleagues, sometimes after many years, and then see what they are doing, find out new developments, etc. So it's better to go beyond the national scale every now and then. And there are, of course, there are other congresses as well that you can go to. For instance, in Vienna, they have the EGU, maybe you've heard of it, European Geophysical Union, and they also have a soil science group, and they also organize many things. So there are several of these platforms, but the International Union of Soil Sciences is an old established union based actually on the national unions.
Mm-hmm.
Yeah.
Is it hard, or are there any requirements to become a member of this kind of unions?
No, it's not very difficult. I think I can only speak for Belgium if it is about the financial things. But if you are a student, then in Belgium, membership is free of the Belgian Soil Science Society. And then you're automatically a member of the International Union of Soil Sciences as well. So it doesn't have to cost you anything. Only when you start to make money in soil science, then they will ask you to pay something. Yeah. Now, rich soil scientists do not exist, so it's not a lot of money they ask, but you have to pay something to keep the union alive. Let's say it like that. Yeah.
But I think it works for exchanging the information and meeting your old colleagues and getting to know more people and what's going on in soil science.
Yeah, exactly. Yeah, it's exchange of information basically. Yeah. And one big advantage of that is when you meet new people or meet old people that you already knew, and you come together, you can start initiatives together, like research programs, etc. Exactly. So some of the things that we have been doing to start IMSOGLO were based on collaborations. I had, for instance, a workshop not so long ago with Daniela Sauer, not so long ago, 6-7 years ago, but some time ago, on a certain topic. And this type of topic now fits nicely within IMSOGLO. So that means you know each other from these type of platforms.
Yeah, exactly. Yeah. And now coming back again to the soil modeling and soil mapping, could you elaborate for our listeners what is soil modeling and why soil modeling is important? Becoming important, let's say, in the future.
Yeah, well, anyway, it's soil modeling. It's what you do is you model, you describe with quantitative equations and quantitative statements what is happening inside the soil. And that's what you want to know. And that means that you usually in many countries, you have a little bit more precipitation than evaporation. So that means you have a leaching environment. Sometimes it's only part of the year that it is leaching. So that means there is probably a downward transport of many stuffs in the soil. It can be water, of course, but it can also be solutions, and it can be clay, or it can be organic matter. So all these things, they can move in the soil. And that's what you want to describe with soil modeling. So that means what do you have to do then? You have to find out what are the processes, how you can quantify them. That's one thing you have to do. And another thing what you have to do is what drives these processes. So if you want downward flow of water, you need rain. So you need to know something about the rain. Well, your soil is the object you want to model. So the rain is at the boundary of that object. It falls on top of the soil, and there the modeling starts. So you need inputs at the boundary. So that's basically what soil modeling is. You are going to quantify, usually by talking to other people, what is happening at the boundary of the soil. For instance, I've been using climate models to get input to the upper boundary of the soil. What is the precipitation, how it's going to change over time, temperature, etc. And then you have to think about the processes in the soil, and they come from research. To quantify these processes, you need research before you can do that. So a soil model actually is something that follows up on research that has been done. So you know at one point in time that the porosity distribution has an influence on the water flow velocity, for instance. If you can quantify that, then you can put it in a model, and then you can run that model if you have the driving force as well, which is the input of water. And so that's in a nutshell what soil modeling is. And then the question is, okay, what are the properties you're interested in? And that depends very much on who you're talking to. In the past, like I said a while before, people were interested in one or two properties like nitrate, pesticides, etc. And now people start to recognize that one property may be very much dependent on another one. So, let's say as an example, if you want to know something about the leaching out of pesticides, then you can maybe recognize that pesticides can absorb on organic matter. So if there is a lot of organic matter, you have a lot of absorption of these pesticides and they don't leach out to the groundwater so easily. So then the question is, how variable is the organic matter content? If you know how variable it is over time, then probably you can say more about pesticide leaching than when you assume it's a constant. So that's already one reason to look at several properties at the same time. And that's why these models are expanding, let's say it like that, in their functionality. And I think that is the future, to do that, because you take more things into account and you have less assumptions on what is constant and what is not constant.
Yes. Yeah. My next question was also this: what's the future of soil modeling? And going beyond, considering the limitations which we have today, going beyond in the future, let's say in 10, 15 years, what would be the future of soil modeling? What we could offer for farmers, and for, as a soil scientist, what we could do with soil modelings?
Yeah, it's a very difficult one, because in 15 years from now, I will be sitting in a chair watching television all day because I'm retired by then. But it's difficult to see. But what I do have in mind is that soil modeling will take several forms. One is the form that it is being used for the development of science. So that you say, let's assume, as people are already doing now, the climate changes in this direction. What will be the consequences? So that's scientific research using a model, trying to build a strong hypothesis on what will happen to the soil if you know what is happening to the soil surface via the precipitation and the temperature. So that's a scientific thing. And for that, you will probably always need these complicated models. But there may also be an applied way of using models. And that is, for instance, if a farmer wants to know at what time he can best give the pesticide, maybe he can link it to climate factors or environmental variables after having used a model, but then it would be a very simple model because not every farmer is a soil scientist by education. And that's one thing that you have often seen already in the past, is that people make a complex model, and when it works well, they are going to reduce it to make it simpler and simpler, and only the essence of the model remains. And that can be used, for instance, in a GIS environment or in a decision support system. And there are many farmers who work with decision support systems. So then let's say the deep knowledge becomes applicable for people who work in the field. And so this is another thing that has already happened in the past. I think there are already advisory systems about nitrogen management in the soil. And they are based actually originally on complicated models, but now they are, let's say, reduced in their complexity, but they still tell the story quite well. And so I see two futures of soil modeling in that sense. The development of complex things to answer scientific questions and maybe to test an hypothesis. So I think this is going to happen, but yeah, it's the wet finger approach. Let's put it in a model and see if it is really going to happen when we do it quantitatively. And the other one is how can we use a model to find out what is the best thing to do in my field given the current weather, for instance. When I was a Ph.D. student, maybe that's a nice story. It's a long time ago, a few centuries ago, but then I was one of the first Ph.D. students working on precision agriculture. And at that point in time, I was trying to use a model that was linked to observations that were made using a sensor, which you held in your hands, which was just measuring the near infrared. And the near infrared was, let's say, a proxy for the amount of leaves that you have. So if you have a higher leaf area index, this means the crop is probably growing quite well. It can take a lot of carbon out of the air. So we combined modeling with these observations, and with that we could find out this is the critical period for the growth in the year. And that's a way to use a model to find out more about how to manage a soil and a crop. And that was experimental at that point in time. But I think people are now very often doing that by using remote sensing pictures or proximal sensing pictures. So that's from a drone or something like that, looking to the near infrared and finding out, something is changing in the leaf area index. We have to act now because otherwise you get drought stress, something like that. And so this knowledge will flow finally to the farmer, and maybe in a different way than when you originally thought about it. But nevertheless, it was useful contribution. At least that's what I always hope to that happens.
You did mention about the droning and near infrared. It comes again to the soil mapping, and why I'm asking what would happen in the future for soil modeling, and now I want to ask what will happen for soil mapping, because I think that the prediction which you made in 2007, and then you really did this IMSOGLO program now, which prepares future professionals in soil science. I think it's a good way of asking you, because it seems to me that you have high predictability based on your experience and knowledge. So what would be the future of soil mapping?
Yeah, that's a good one. In the past, let's say 30 years ago, something like that, people were mapping soil names, basically. They made a soil map, and on the soil map was a name of the soil type. This type of mapping is becoming rare because these type of soil maps have been made, and that is no longer so relevant. People are now more interested in certain properties that are, let's say, hot. And hot can mean it's something about the change in carbon content over a year. So then you're not mapping, but you are repeating mapping over time. So that you're actually monitoring, but monitoring in a spatial sense. So you are making a map now, and you are making another map in a year from now, and then you look at the difference. So this type of soil mapping based on less properties, and not a complete map unit code, but just a few properties, but repeated over time to find out what are changes, and are these changes of spatial nature, or are they just of temporal nature? Is it just a change over time, or can you also see that some part of the area is developing differently than another part of the area? I think these type of questions will come more and more often. So the future of soil mapping dedicated to a few parameters and repeated in time. That would be my guess. What would happen? Yeah.
Also, combination of soil modeling and soil mapping, would these two reduce the field experiments? Because as you said, if we have enough data, would be there still need or importance of having field measurements, like digging the soil or doing it with our hands?
Yeah. I would always say ground truth is very important. So ground truth, by that I mean digging a pit, looking not only what is at the surface, what you could also measure, but also what's the variation over depth of the soil properties. And that's highly important, because not every depth pattern can be captured, let's say, by some kind of sensor. So there are people, and I cannot say I don't like them, but I'm not in favor of their work, that say, well, we have a satellite, and this satellite tells me what happens with the soil moisture at the soil surface, and that's all I need to know. Because that's totally rubbish. If the water infiltrates in the top of the soil, and you can see that by your satellite, you don't know what it will do at 5 centimeter depth. Maybe if you're lucky, you can still find some crop response, but maybe there is water stagnation at some point, and maybe there's no water stagnation at another point, and you can never find out by using just the satellite data for that. So you need depth data as well, and for that you need a way to find out what is the depth variation, and sometimes that is done via sensor types of measurement, but in very many occasions you still have to look in a pit what is actually happening over there. And I don't know if you're probably also very active on LinkedIn. There is one guy on LinkedIn. He's John Rasick, he's called. I don't know if you've ever seen his name, but he's always making advertisement. Don't just look at the surface, dig a pit. That's basically his main statement. And he gives a beautiful picture of variation over depth, which is so huge that you could never capture it when just looking at the surface. And this is, he is giving, try to contact to him, and you can see all the pictures that you want to see, and the story tells itself. And so it's really useful to dig in the soil, to look at the soil, try to interpret it, try to understand it, and then you can maybe with other measurements have a more complete picture, but don't stop at the surface with some cheap or expensive sensor, because you will miss a lot. That would be my statement, I guess. So what does that mean? Modeling, because you could also say a combination of modeling and digital soil mapping, or induced statistical mapping, it can, let's say, result in a lot of information. Is that all you need, or do you need fieldwork? I would say you still need fieldwork. You will always need fieldwork. But I think you have three sources of information now. It's the sensor measurement, it's the modeling, and it's the regular classical fieldwork, and they all add up. So they just put you in a situation where you have a lot of information available, and you can make better decisions based on that. So don't throw away any one of these three components, because you are going to throw away what you just gained, and you lose it again. Yeah. So that's what I would say. That means that we can get over time more and more precise, more and more accurate with what we predict, because we have got several sources of information, while in the past we only had one, which was a soil map, and this didn't tell you too much about variability, didn't tell you too much about the dynamics over time, because it was static. And now we can do much better than that, and that's a good development, I think.
Yes, I do agree with what you said. Especially in first semester, I would think that knowing, just having more data from the sensors and like being able to use the data statistics, that's enough. But when I was introduced, it was Professor Daniela Sauer's course. And when she started to tell us that we need to dig and really study the history and geology, which could really explain us why this soil looks like this. And I think that course really covered the knowledge gap, which I had. Yes.
Yeah. That's a very important type of course. Yeah. It is often, you could see as a problem that it is usually observational and not so much quantitative. So you can say that's a little bit difficult to understand because you don't have a number, and numbers are usually making understanding easier. But on the other hand, it's so much information that is useful that it is essential to any course on soil science, that you also look into the soil and indeed look to the geology as well, because the geology delivers you the parent material in which the soil will form, and it's a starting point. If you don't know the starting point, how can you tell where it's going to end?
Yes, I agree. I mean, of course, sensors, everything can give us the quantitative data, but logical thinking is up to us. So to have a logical thinking, we need to really dig the soil and have a look at the layers and study the history. Yes.
Yeah. You have to make an interpretation, and it's easier to make an interpretation when you have seen it in the field than when you just have a lot of numbers.
Exactly. Yeah. And you were also mentioning your PhD, and also mentioning some of your colleagues who are working in the same area. Now I want to get a little bit zoom out and ask about the people who really influenced in you personally, and also your work and your research. Were there any person or people whose influence was essential in your work and in your career?
Yeah, I think if I would have to name people, I would probably name two. And one of them is, I'm not an old-fashioned master student. It has a different name, my study, but it equivalent to a master, I would say. So my professor during my master phase was in University of Amsterdam, because that's where I did my master. And his name was Jan Sevink, Professor Sevink. He's now an old guy, 80 years old, but still digging pits, etc., and still writing articles. So he's still active. And he was, I liked him a lot because he was, it was a source of inspiration. So he was so much driven to look at soils and make interpretations of it that it was very contagious. Yeah? So we were doing field work for our studies, and he came over for 2 days, and we had enough inspiration to continue for 3 weeks, like that. So that would be one person. And I've been working with him later as well, so it was quite nice. He was in my Ph.D. committee later to comment on my work, and later I was in a Ph.D. committee of one of his students. So this circles around. We are circling around each other still, and that's nice actually, because you see how he developed, and he can see how I developed, and that's always inspirational. And the second person that I would like to mention was Professor Johan Bauma. He was on Wageningen University. And he's also retired, also quite 80, but also still publishing. And these are the kind of people that they will drop dead behind their desk, I guess, at one point in time. And he's a very inspirational figure. He also had many prizes. He won many prizes as a scientist. This is in International Union of Soil Sciences. They have these prizes every few years, and he was one of the prize winners based on his full career. And he was more or less the inventor, one could say, of precision agriculture. And that was in the 1980s. So he invented the word and he invented the activities. And he was also a soil physicist. So he was water flow, modeling, sampling soil for the determination of hydraulic properties. He was also one of the first persons doing that systematically and well organized. So he would also be a name that I would mention. Also an inspirational man. And I have also still contact with him every now and then. So for instance, I think 2 or 3 years ago, we had a big workshop in Ghent on, on the occasion of a personal doctorate, a special doctorate for somebody else. But we have a conference which was about, let's say, the future of the planet and the planetary boundaries and things like that. And we asked him, I personally asked him, can you deliver a lecture on your work and the relevance for that topic? Now, he had a lecture and the whole room was at 200, 300 people. They were all applauding for him. And I said, yes, you're still in business. Good. And so that was, it's always nice to have people in your past that you can still see in your present. Well, now I'm almost retired myself, and these people are still active. Very nice. Yeah. So these were inspirations. Yeah.
Mm-hmm. If you could name, were there any lessons you learned? I assume that they were very experienced and they had a lot to teach. But if you could name few things which you learned from them as a life lesson.
Okay. I think I can. For the prof in my PhD phase, so that's Johan Bauma, I can better answer it because he was involved 4 years with my research, and the other one was just for the thesis, which was a shorter period of time. But for Johan Bauma, the thing is, he was one who said, shouldn't you think about that? And that was a sentence of 5-6 words, and then it makes you think, and then not a bad idea. And then he creates the circumstances under which it can work. That means he said, well, if you go to that place, you can ask somebody else the details, and I will bring you into contact with this guy. And then if you come back, you tell me what you learned. So he leaves the initiative mostly to yourself, but he just pushes you on the right track. And that's the kind of work that worked for me, at least the kind of method that worked for me very well. So you need, you get a push, you need to have a direction. And when he gave the direction, he said, well, you try out for yourself. And if you get stuck, you can always come back. But that's, of course, if you are a little bit a proud person, then you are not going back. You try to find out by yourself. And that's a good start. No? And so this is, you could call this a life lesson. If I have a student now, a master's student or even a PhD student, I also try to do that myself. So I give them a push. I think this is a new topic. Nobody has written about it. Give it a try. And if you need help, I know some people, I know how to do it perhaps, but first think for yourself. Mm-hmm. And this is a way that keeps people motivated to do their work because they are more or less, to some degree, the inventor of the topic. And they get a push, but then they have to invent it by themselves. So if there is a life lesson, I think that's a life lesson. Don't define too precisely what people should do, but just give them a push.
Mm-hmm.
Yeah.
That really explains my supervisor, Eugenio Diaz, who I have now. He also gives some hint, but he doesn't. I know what he's doing. He wants me to learn more, and he just gives me hint. You could try this. You could try this.
Yeah.
You could ask that person, but he never, in detail, explains what would happen there or what that person would say. Right?
Yeah.
He just wants me to learn it myself.
Yeah. Mm-hmm. Yeah. I think that's a good initiative, and also it makes it easier for a thesis promoter to work, because otherwise, if he would describe to you exactly what you should do, then you would probably come back with a lot of detailed questions because you don't have the stimulus so much to look it for yourself because you know he's going to tell me anyway. And then in that case, you learn less. So it's better for him to do it that way. It's also less work for him to do it that way. But the best students, they will certainly benefit from it. And if you are having trouble capturing the topic, then maybe another push is necessary. But you should not push too hard, too much in the beginning for sure of a thesis. Yeah. So that's a good way of doing it. Yeah.
I think it's for future scientists a perfect environment building and motivation for them.
Yeah, I think so.
I do agree. Also, I want to ask about the books. Were there any books which really you like reading or rereading sometimes, or affected your life personally or your career?
Okay. Well, I do read books from literature, but actually they very rarely really inspire me. And that's because they often lack something that I found very interesting, and that is that they play in a landscape and that they tell something about the relation between people and the landscape. That's the kind of books that I like best. And I've got 2 examples, and one of them you surely know, Lord of the Rings. You know that one? Yeah.
Yes, I've watched the movie, but I haven't read.
Okay. Well, and when I was a student, that was on high school, you have for your book list, you had to read an English book. And then I saw Lord of the Rings. It counts for 3 books because it's also 3 movies, no? And I said, oh, well, let's do that because then it goes quicker with my book list. And then I started the book and then I opened it and said, oh, wow, it's more than 1,000 pages in English. And you're just, what was I, 16 or something like that. But then I started reading it and it caught me so much that I read the whole book in one weekend. And then after that, I was a little bit, mentally,
living in different world.
Yes, exactly. Yeah. But the thing that was interesting is not because it is some kind of, mythical, type of adventures, but also because it describes the landscape where people are and the landscapes where people can live, where they cannot live, and what's the effect that people have on landscapes. You can see that back in that book. If you go to Mordor, you know what people can do wrong, no? Yes. And if you go to other series of the same writer of Tolkien, then you see that there are also, for instance, stories about the Endwives. Did you ever hear about the Endwives? You've got
I cannot remember it now, but
you got the Ent in Lord of the Rings. That's a guy who lives in the forest, a shepherd of the tree, very large, strong. Yeah. Well, there is mythology around it. There was in the past. There were also the Endwives. And the Ents were guarding the forest, and the Endwives were doing agriculture. So they were living in different worlds. So at one point in time, I thought, well, maybe we should call IMSOGLO the Ent specialization and the Endwife specialization. But then I thought, no, let's make it more serious. But anyway, that also tells you that picture that the writer Tolkien had in mind about the influence of people, or let's say representations of people on the landscape. So that I found very attractive. And there is another set of books that I also like, and actually for the same reason, and that's a science fiction type of book. It's called Heliconia. It's a series of 3 books. And it's about, it's very complicated, but a planet that is captured by another star. And when it comes from a first star, so the planet is now circling around 2 stars. And one star is very weak and one is very strong. So when it's close to one star, it becomes very hot. And when it is to the other star, it becomes very cold. So you have ice ages. And that they exchange every 500-600 years, something like a regular ice age, one would almost say. It's a little bit longer here, but anyway. And then this book tells you what is the effect on the people. How do the people cope with that? Because if you're going from a very hot situation and you go to an ice age in a matter of a few centuries, then it means that the people have to evolve. And they bring it into contact with, there is a certain virus that make the people adaptable to the new climate. And, but only certain parts of the landscape. And I said, that's an interesting book. It's the landscape, it's the people, it's the interaction. So that's the type of book that I like a lot. And actually, it's not on anyone's literature list, or maybe Lord of the Rings, but it's just the type of books that I like best.
Yes, I think the Lord of the Rings. Have you ever watched the movies?
Yeah. Sure. Yeah.
Yes. but I think this kind of movies really, when you start to think about the movies, it really develops your logical thinking, like what's happening. And also, two different stars, as you mentioned, right? How they affect. I think that really does sci-fi movies and books. They do really develop your logical thinking.
Yeah.
And sometimes they might give you an idea.
Yeah, sure. I mean, if you look to this Heliconia series, if you have an ice age and then you have a hot period, and you have, in addition to that, some geological changes, then you could almost build a soil model about it. Huh? All the drivers are there. So yeah, that's interesting. Sure. Yeah.
But I'm more interested in future AI, how robots become. They usually show it as bad guys, but I think I have a different opinion on AI, and also parallel worlds, etc. But now I really want to come back to the future and technology. We see that the future is technology, that's for sure. And AI and machine learning are being applied widely in almost in all science areas, even in psychology. Whereas having skills in data analysis, like statistics, is not a skill, it's a requirement today. It's for sure a skill, but it's a requirement which you already should have in the scientific area.
Yeah.
What skills are important for future students today? Where they should pay their attention, what they should learn, and what skills would be needed for the future students?
Yeah, well, we have been discussing already a little bit about that there will be much more data of different kinds becoming available. So about modeling, sensor measurements, and still the traditional fieldwork. That's a lot of data. So I think what the future student should be able to do is work with big data. And that can make necessary that you look to certain methodologies like artificial intelligence and all kinds of methods that are suitable to learn a lot from data without really understanding the structure of the data. So in that sense, I think AI, machine learning are very useful methods to be learned by students, for the reason that it will help them to try to identify patterns in the huge amount of data that they will have. On the other hand, I'm also a little bit, well, not skeptical, but a little bit careful by not trusting completely on AI and machine learning, because you will get an answer for sure. But will this answer will it be, let's say, portable to another situation? So if I see a pattern with the AI and with the machine learning, and this pattern is, for instance, a spatial pattern or whatever of a certain property, and I can map it very precisely, then how can I be sure that this will also work in another area where the data are not really much different? Can I be sure about it, or should I do a validation study always? And so I'm always a bit critical there. AI, it can help you to recognize patterns. Yeah, very good, because it's often not possible to do that in a very big heap of data just by using your eyes and your spreadsheet and whatever. But try to connect it back to the field and try to find out if it is, I call it transportable or portable to another situation. Like portability of software on one computer and another computer, will it also work? ? Well, the same is the case with data. Is it portable from one landscape or from one situation to another one? If it is not portable, then you're actually, with your techniques, you're doing extrapolation, because you do not know what it is, and you're extrapolating. And extrapolating is a risk, because your uncertainty will rapidly increase when you're doing extrapolation. So I think one thing that students who work with these modern methods, which is essential, should be aware of the risk of extrapolation, because otherwise they may draw conclusions that are not valid everywhere. So the story is, as usual, much more complex than one would like. I think you need the techniques. Without the techniques, you cannot survive in the modern world with a lot of data. But remain critical, and also try to find teachers who will keep you critical there. Don't believe everything that rolls out of the computer. That's what I would say.
I do agree. Critical thinking is very essential, especially if you're pursuing a scientific career.
Yeah, sure.
And as I said, scientific career, what advice would you give for students who are about to pursue a scientific career? Or in other words, I would put it, what advice would you give to your younger self?
To my younger self? Do what you like. That's what I have done always, actually. My career is not far from standard, I should say, because I did my master in Amsterdam, and I then had a Ph.D. in Wageningen, had several jobs in Wageningen, and then I came to Ghent, and I already switched faculties in Ghent. So that means every 7 years I had a different job, apparently. But it was always a fixed appointment, so I was never worried about position, how temporal to be, etc. And the strange thing about my career was, after my PhD, I went into management, research management. And then after some 10, 15 years, I got tired of it. And now I started to do research only later. So I don't have a typical career, I would say, because most people do their PhD, they do a postdoc, they want to become a professor, etc. That's the usual pathway. And when you become a professor, management increases by itself. So if you want to pursue an academic career, you should first, I think very clearly, what is driving you? What gives you the fun? And if it doesn't give you the fun after a number of years, well, don't stay there. Go somewhere else. So that would be my advice. Always follow your heart in a way. And if you have to, because many people, they say, oh yeah, my career is a PhD, postdoc, because one postdoc is never enough. Maybe assistant professor, associate professor, full professor. And then I hope to be retiring. Yeah. But that's a boring career, isn't it?
Yes. When I was preparing for this interview, I was reading about your research background, and I was quite confused. Yeah. And I was rechecking, is it really you, one of the co-authors? Because the paper name seemed rather, it's not your research area. But yeah.
Oh, there are other guys with my name. There is one guy in Germany who does something on sociology.
Yes, I was quite confused, but still.
That's not me. No. But you were asking for advice. If somebody wants to pursue an academic career. Well, the thing is, many people, especially students from IMSOGLO, I think, because I've written a lot of recommendation letters already for people from IMSOGLO. I think I've written about 40 recommendation letters already for 2 intakes. Wow. And I know that for the first intake, more than half of the students is now doing a PhD. And the second intake is also already quite a number who have their PhD. They got the job, and they still have to start it, but they got the job. So that means PhD is interesting for students. I can imagine that, because you can do research, and if that drives you, it's nice. But I would always say, be careful. Don't take just any PhD position because it will give you the title. Because that is not going to be sufficient to keep you moving. Because a PhD can have very hard periods inside. You can have to do maybe months and months of lab work without any visible results. And then maybe after 2 years, the first results come out, and then you can start writing. Well, the first 2 years can be very difficult then. So then you have to have a driver. You have to get a motivation from something. And that should be coming from out of yourself, and it can never be just, I want this degree. So if I would give an advice to somebody who wants a PhD, okay, choose your PhD, but also choose your topic very carefully. You really have to like it, because otherwise it's not going to be easy for sure, and maybe not successful even. So that would be my advice. And if you pursue a non-academic career, then I say, well, you're completely right. Why not? Because I've done that as well. Yeah.
Yes.
So, yeah.
I think that's an important lesson, because right now, where I have to decide where I should go, stay rather in scientific area, or go and learn more about AI and machine learning. So I think that was a very important lesson for me. And advice for me, yeah. Well, and you can even you name now 2 things, but you could easily combine them probably in a PhD as well. Later on in my career, I think it's more about keeping your curiosity alive rather than pursuing and what will people say, or just having the titles, right?
Yeah, people always say, don't go for your final destination, but go for the road. The road is more important than the destination. And I think that's right, because the road can keep you motivated. The destination can keep you motivated for a while, but not indefinitely. So that would be,
Yes,
at least that's how it worked for me. Yeah.
Yeah. I did talk with quite amount of people who are doing their PhD, and I think they weren't as much motivated, and what they would, not all of them, but some of them would say that maybe it's not a good thing to do a PhD. It's just from their experience that they didn't enjoy it as much as they would. And I think they didn't even choose the topic they liked. And that's how they really, you cannot see from these people curiosity at that point.
Yeah. And if you do a PhD, if there is no curiosity, then there will probably also not be interesting results.
Exactly.
Because curiosity makes you creative, and that's what you need. It shouldn't be a mechanic activity doing a PhD, because it will not work.
Exactly.
Yeah, maybe if you are an engineer who looks to concrete or something like that, maybe then you can do it that way. But if you want to do something in earth sciences, you have to be creative. You have to look across the borders, and that it will probably inspire you more even. Yeah.
Yes. When I also started this podcast, I was also quite inspired, and that's not what someone else telling me, or that's what drives me. Also, I was thinking, I could also make short documentary movies, but it's in the future. But still, I think that would be interesting for me to make my own investigation in this field.
Of course, right? You're now practicing something that may in a few years from now be your profession. Even it's possible. That's good. Yeah, if you are interested, then you should try it out. Yeah.
Why not? And I could be a professor as you after 70 or 50 years. I would be telling, I was this podcaster.
Yeah. I'm now a professional podcaster, but I started as a soil scientist. Why not?
Yes. Yeah. And thank you very much for this very interesting episode. And now I have some of the general questions, and it's up to you how you would answer them. Are you scared of climate change and future consequences of climate change?
Well, not scared, but worried. Let me explain that a little bit. Just today, there was a message coming out for the Dutch people who were collaborating to the IPCC reports. And they say, we no longer believe that the 1 or 2 degrees increase in temperature is feasible. We have missed the opportunity. That's what the scientists said. And that doesn't make you happy when you hear that, of course. And they say, well, we should be happy if it becomes 3. So then you say, are you scared? Well, no, I'm not scared, but I'm worried, because there will be consequences that we will all suffer from. And I don't know how fast. Probably my age, I will not have too much experience with that. But my grandchildren, if they ever come, they will have quite a different world to live in. So you have to start thinking about the consequences indeed of climate change, rather than trying to reduce the climate change. At least not trust the politicians to arrange it for you. So I once had a very small interview as well for some Belgium group where they interviewed scientists about how can we prevent the climate change to run out of hand, let's say it like that. And then I thought about it, and I thought, well, there are 2 things. You can trust the politicians that they will arrange it for you. They will make new rules, new laws, etc. Or you can do the maximum by yourself. And then I thought about it, and I think, well, the dynamics of politicians is that every 4 years or every 5 years, they change their opinion. Long-term policies hardly exist. Don't trust them too much. Better do it by yourself. So I thought to myself, okay, what can I do by myself? Buy an electric car if you can afford it. Eat less meat. What else? Not 20 degrees on your central heating system, but maybe 18 or 17 is enough. So these are the things you can do by yourself. And if everybody would do that, we're already doing a lot. So that would be my feeling. And don't trust the general politician groups and let's say even the European Union ambition levels too much, because they are too fluid. They change all the time, and I'm not too positive about it. So that means climate change is probably going to happen in a worse degree than we would expect 10 years ago. Let's say it like that. And that means you have to prepare a little bit for consequences, I think. Yeah, in what way? Well, don't build your house next to the river, maybe. I mean, it's not so long ago that large areas in the Netherlands, they have these floodplains and people were building houses there because the soil was very cheap to build on. Yeah, they found out why it was so cheap, because it came underwater every 15 years. Then you can,
especially now, most of the European people are buying houses next to the river, ocean.
Yeah. So, and what else can you do as a private person? Well, if you have a house, maybe not all concrete around it, but grassland. These kinds of things you can do, many small things, and that will help, I think. So that's good, but also prepare for consequences if you can. So what does it mean? Live on the first floor? No, that's a joke, but it's something. Yeah, maybe move. And when I retire, I will retire in a few years. I'm seriously thinking maybe I should move to Sweden and not back to the Netherlands. I come from the Netherlands, and I can swim, but I don't want to swim all day. So maybe I should go to Sweden. It's higher up. It's also not so warm. So these are the consequences that you can think about. Yeah. But,
for the people who really don't take climate change seriously, the severity of the climate change, could you mention some of the consequences?
There are a lot of consequences. So what can you think about? You can think about, depending on where you are, but in the northwestern Europe, it's the frequency of intensive rainfall, but at the same time also long dry periods, which will kill harvests. At least it will affect the harvests. That's one thing. But there is another thing there's a socio-economic impact. So people will come from areas where the effects are worse than in northwestern Europe, and they will come to you as refugees, climate refugees. And then that's a consequence I'm more worried about actually than just the temperature change. Because if people start moving all over the globe with a motivation that's completely logical, they just want to save their life and their livelihood. So it's completely logical. But is it feasible to deal with? That's a problem. So we will probably have conflicts arising from that. And maybe a few of the conflicts in the world that we have today can already be associated to climate change. Many people from Africa are going to Europe. And why is that? Because agriculture is getting more difficult because there are more dry periods. So the motivation for them to come to this place is completely right, because it's better for them. But can it be afforded or can it be maintained? If it's not 100,000 people, but if it is 10 million people, question mark, I don't know. So these are the things that make me worried a little bit. And we have to see how this develops.
That's also what worries me is the possibility of a rising war, like pressure between the countries for the land, and then limited resource, especially phosphorus. I always mention phosphorus. And then I'm really scared that there would be a third world war, which will completely destroy our species. It's a possibility you cannot exclude, and that's something that can make you worried. Yeah, sure. Okay. But on the other hand, you can also think, what can I as a person do about it? Exactly.
So don't think too much about it because it's outside your control anyway.
One of the things I've noticed about climate change, I will just mention this. Climate change is about everything. It touches upon every field of your life. That's why people don't want to discuss it. They feel stressed. They feel depressed because they cannot take control of everything, especially politics, everything. That's why they don't want to discuss this topic, or they don't want to do anything. But it's rather better that you change your behavior than changing everyone else's behavior. That's, I think, also what you were saying.
Yeah. That's more feasible, better feasible. I mean, you can identify some actions that will be a contribution for sure. And then the only thing that you cannot influence is how many people will do that. And actually, the politicians should take care of that. They should make the whole population move in a certain direction, by having legislation, by having stimulation, etc. If they don't do it, then it's the private initiative. And how can you do private initiative? In these days, it's easier than ever before because you got social media and you can organize yourself very easily. Mm-hmm. So that's let's say a sign of hope, I would say. People are able to organize themselves, and they are organizing themselves, but it's also so that people are organizing themselves who are completely ignorant, who are doomsday preppers, etc., and they are also organizing themselves. Mm-hmm. And that's a disadvantage of the same social media. So what can you say about it? You cannot exclude some people doing one thing while the other people do something else. That's not possible. Yeah.
Mm-hmm. Yes. Mm. And for the next question, what's your favorite thing about science and soil science?
Oh, that's a good one. Favorite about science? Well, the fact that you are doing something that is likely reproducible. So you're finding out something, you're making measurements, you're doing modeling, etc. And you are finding something, you're drawing a conclusion, and you do it in such a way, because it is scientific, that it should be reproducible, at least in the same area. And that gives a good feeling, because then you can say, I contributed something to the general knowledge. And what did I contribute? Well, this and this and this. And if you don't believe me, you can check it for yourself and you will find out the same. That would be very positive about science. No, it's better than an opinion. Science is better than an opinion. And that's a strong point of science. And soil science is no exception there, I would say. So my favorite thing about soil science, what would it be? Well, for me, it's modeling. I'm really fond of modeling. I know. Ideally, I always say, joking to my former colleagues, I'm making a model of everything, but you're not yet in it. So it's just a hobby. It's a hobby that I made into my work. Now, okay, that's nice if you can do that. But in fact, it's the same. If I make this model and I predict something, and then what I want is that somebody else try to invalidate it. So with his own model or her own model, or with the same model or whatever, but try to find out what is wrong about it. And if there is nothing wrong, then it is right. That's a philosophical principle. And this philosophical principle, that's the nice thing about science. If people cannot invalidate your work, it is automated after some time. And then it means you have created something that other people can use. And that's nice about science. That's nice about soil science in general. And any science is the same, I think. Mm-hmm. The only thing that only sometimes for sociological studies, it's more difficult because it's very empirical, and it usually depends on the population you are looking at. So sometimes it is a finding, and then this finding cannot really be reproduced because you are going to another population. Mm-hmm. And the nice thing about, let's say, more the exact sciences is that if you quantify a process, and this process is a natural process of which people know how it works, then there is no other way. Gravity will always work towards the center of the earth. And what else? Water flow from low to high potential, or from high to low potential. Sorry, the other way around. So that means there are some principles behind it. And if you put these principles in the models, then you can be more certain about the reliability of the outcome. And that's the nice thing about, let's say, beta sciences when you compare it to some alpha sciences. Mm-hmm. And but both are science, and both aim at maximal reproductivity, I think, in the research.
Mm-hmm. Yeah. What advice would you give to all students?
To all students? Mm-hmm. Sleep minimally 6 hours per day. What can I say? What we did, maybe, I don't know if you already saw it, but we have, for the new generation of students, we made on the IMSOGLO website, we made a page for freshmen. We call it for freshmen, info for freshmen. It's for people who just start. And I wrote that page, and these are actually my advices to new students, and maybe not all students, but new students. And what are these advices? If you have a question, ask it. And you can say, that's easy, but that's not easy, because there are many cultural differences over the world, and people from some parts of the world will never dare to ask a question because they are afraid that they will be eaten. Mm-hmm. And usually we are not very hungry. So that's that is actually not a problem. So this is one advice. If you have a question, ask it and don't wait asking it. Ask it as soon as possible. Maybe one-to-one after class or in class if you don't fear anyone else in the class. So that's an important one. And another one is follow up. So if you have learned something or you got a task, don't postpone it. Do it immediately, because then you will find out the problems. Then you can ask the question without being over time. Let's say it like that. And then it's easier to recuperate or to restore. You don't have a back lag on the rest of the group. Mm-hmm. So these are my advices: always follow up and always ask questions. And maybe these would be my advices for not everybody in the world, because some groups in the world, they don't have any restriction in that sense. I come from the Netherlands. Now, well, if you're in the Netherlands, people will ask you immediately everything. They can make you very tired that way. But if you go to other parts of the world, I shouldn't name a country, but it's usually in Southeast Asia, you have a more timid type of people because they look very high up to the professors and they will not easily ask
where
a
I'm
question.
from. Mm-hmm. Sorry to interrupt, but it's very true. Where I'm from, we never ask professors a question.
And it's a bit a cultural thing. It's also a bit of maybe development that still has to come. I don't know. But when you are doing your study in Europe, it's important to start having that property that you ask questions, even if your background is different, because it will help you a lot in Europe at least. Yeah, and I mean, it was not always like that in Europe. When I was a master student, I once had a question about weathering, something chemical. And I asked in the class, and this professor, very old-fashioned guy, he said, "Are you mad that you don't know that?" Then I said, "Well, okay, I don't ask any more questions. I read the book." It's not stimulating, eh? Exactly. And this happened in Europe also in the past, but I think it has changed over time, and that's because people are more open. But it's 20 years ago, it was still different. So I think maybe it's a development taking place everywhere, but the starting point is not the same for everybody. Mm-hmm. So these are my advices.
Yes, I do agree with the part where you said not asking the question. Where I came from Asia, Central Asia, but not always happens, as I said before, but it happens quite often that students don't interact with the professors. And other point you mentioned, if you have a task, do it right away and don't procrastinate. But as a student, as a procrastinator student, what's the best way not to procrastinate, like from your own experience? What do you have any technique or method?
Technique? It's a long time ago that I was a student there, so this is a remote memory. But what I usually did is that the evening after class, I very briefly repeated what I noted, so that I understood my own notes. Because I don't know if you've ever seen my handwriting; it's quite horrible. So I have even problems reading my own handwriting. So what I did in the evening is I went over my notes. And then, okay. And then suddenly it burns into your mind better and remember it better. And it's easy for you to make an exercise if necessary. So repetition, and don't wait too long with the repetition. I think in Belgium, it's very often with students, it's a habit. The exams are coming. Let's start to look at the topic. It's too late. It's too late. That's what I think I do. Yeah. Because you have many topics, and then you get some people who can learn very well. They learn a topic, and they have to do the exam tomorrow. So that day they know everything, and 2 days later they forgot everything. And then I think, then the investment is not good, eh? Because and I've seen it. I've been taking some. Maybe I'm not going to mention any names, but I've been taking some oral second exams on video, and some people you see they haven't put much time in it, and then the second result is worse than the first result. And it is often a matter of repeating in time and daring to ask questions even after a few months after the first exam. Why not? It's not forbidden, eh? I mean, the worst that can happen is that I, in my case, would say, well, I can give you the answer in 2 days, but not right now because I'm fully occupied. That's something what can happen, but so don't do it 2 days before the exam. But but anyway, that's it's good to ask questions even in the second phase when you have to redo something. Yeah,
exactly. It's hard to came to one. I guess for me it was a realization and self-consciousness of what I'm doing and why I'm doing. Trying to ask myself the question. I think it came rather late, but still now when I'm learning something, I just look at the goals, aims, why I'm learning this. Is it important for me to understand and why I'm wasting my time on this? So I think self-realization and consciousness of the student is also important. And as you mentioned, one of my culture shocks in Belgium was all the students all this time, they're chilling, they're drinking outside, but I was surprised when do they study? When do they have time to study?
Yeah, well, like I said, the Belgian students, many of them at least, they start studying in 2 weeks before the exam start, and then they hope for an exam schedule that they have one exam every week, so that they have that they can follow, that they can prepare for the exam by starting 1 week before the exam, and they hope it's enough. And when it is not enough, then they are in trouble. So that's why I say if you repeat a little bit, not phonetically, but a little bit after the class, it's probably more efficient to stay in your mind, to keep it in your mind that way. And then you still have to repeat it before the exam, but it's probably better than just try to drown it with beer and etc. over the year and then assuming that it will come back in 1 week study. Maybe not.
I heard that one of the secrets of Belgium students starting with drinking beer.
Yeah, we have so many types of beer. It's exactly. Maybe, I don't know. I'm a Dutch student, so I cannot really tell.
Okay. One of the questions which I always ask from my guests is, what is the meaning of life?
It's a movie by what is it called? John Cleese and these guys. Do you know it? No, you don't know it.
I don't
it's
think
it's the title of a movie.
Oh.
That's not what you want to hear, of course. But it's a movie of Monty Python. Monty Python was a group of absurdistic theater makers 20, 30 years ago. And they gave it the title not for nothing. They say the meaning of life, there is no meaning of life. It's all rubbish. And let's have a lot of fun. That was their opinion about the meaning of life. My opinion about the meaning of life is maybe a little bit different. But what should I say? The meaning of life. I think the meaning of life is to make a future for your successor. So not in profession, but your successors in life. You know, that's your family, maybe some students that you have close contact with, etc. So to create good circumstances for the ones that come after you. That's the meaning of life. So that's actually, it's more or less an evolutionary way of looking at it. Stimulate evolution. That's the meaning of life.
Yes. Being useful for others.
Yeah,
contributing.
Exactly. Yeah. Not drinking beer anyway. I like beer, but it's not that's not the essence.
Well, then that was a lie. One of the students lied to me. They said that the secret is drinking beer when you are preparing for the exam.
Okay. Oh, well, I don't know. Did you ask later for his marks?
Well, I should say it didn't help. I already proved it on myself.
Okay.
As you know, it didn't help.
No, not always anyway. Yeah. Okay. Yeah.
Yes. Yeah. Also, what you said about the movie, I recently watched one movie, Everything, Everywhere, All at Once. So it's just thinking about, if you really think about the meaning of life, there is no meaning of life for all of us, but as a person, you can find the meaning of life. So what I like that movie is that there is no meaning of life, of course, but you should always look for positive things and try to find one as well.
Yeah. That's the way to keep yourself motivated. I mean, the meaning of life, that's what motivates you. And then maybe you don't know, maybe you cannot express it in words. What is the meaning of life? But if you know what motivates you and you do that, then you are following up on the meaning of life. And then you are having defined it for yourself, maybe not in words, but in deeds. But that's good enough.
Mm-hmm. Yeah. And as it comes to you, do you think have lived, fulfilled the meaning of your life so far?
No.
What is missing?
What is missing? No, I don't know what will come. I mean, I don't feel like somebody who is going to die in the evening tonight. So that means I still have to do something. Mm-hmm. And what I will have to do is probably something that I find nice to do and which I think that delivers something. So that means my meaning of life is not yet fulfilled. In a way, my motivation is still going on. So there is something missing, yes, because I'm not finished. But what is missing, I cannot really tell you. That's a difficult one.
Yes.
Yeah. But anyway, if it is about personal motivation, I've mentioned a little bit that I took different jobs, different places, and changed every now and then. And that was actually to fulfill the meaning of life for me personally. Yeah? Because if you notice that your motivation for a certain kind of job is failing, then maybe the results are still good. So you can have, for instance, when I was in management, the results can be that you have that you could hire more people because there was more budget. You could say, that's positive. But if it doesn't inspire you anymore, then it's better to stop or to do something else. Well, that's something that I always have tried to do in my life. And I was lucky that my family would follow me because that you have to have that situation as well. And then you are, then you can continue pursuing the meaning of life, pursuing your motivation. And that's not yet ended, I guess. Although I will retire in a few years from now, but then I can still do something else, no?
Mm-hmm. I think you would be still working and contributing.
My wife wants, maybe not. Yeah, well, yeah, I'm making jokes to my wife all the time. She wants to make chocolate, praline, so bonbons, and she is taking courses on that, and she's developing that. And I said, well, you're making a factory, and I'm going to do the management. So that's something else.
It's quite a good team, right?
Yeah, well, yeah. I eat it. Usually I only eat chocolate. I don't make it, but yeah. So that would be no soul science for sure, if it would be like that.
Yeah, but still you're still pursuing, finding some meaning, right?
Yeah.
And one of the last questions, how and where our listeners can find you online?
You mean my sound, because they are listeners, or your listeners?
Yes. Yeah, well, let's say in this episode, both of our listeners.
Okay, I have a website at the Ghent University, and you can easily find it. You just Google Solgen, that's the name of my model, and my last name, Solgen and Finke, and it should be the first hit, so that was easy to find that page. I have started a LinkedIn group for people interested in Solgen, or no, interested in IMSOGLO, I should say, and there I post things, especially jobs that I find for the people, and sometimes things about the follow-up of the program, etc. So these two places, I have my own LinkedIn. Apart from that, I don't do Facebook anymore because they kill your privacy, and some other things I never started. So I'm not very active on the internet, but these three things. So that's LinkedIn and my own website and LinkedIn 2 times. That's probably what I do. Yeah.
Mm-hmm. Yeah. Also, all the social media and also Google Scholar university account would be in the description of this episode. And as for you, Professor, I really appreciate that you made some time to make this episode and also shared with your own personal experience, also making the jokes. I know that you are really good at also on your teaching. Yes. And also answering the questions sincerely, taking them seriously, and also making contribution and being part of this episode. And thank you so much.
It was my pleasure to do so. And I hope you can make a nice podcast out of it. Yeah.
Yes. Thank you. Okay, our listeners, I hope you enjoyed this episode. So bye.
It's nice. Bye-bye.